We're going to start this video with a quick overview of what we already know about factoring, and then talk about one other strategy. So, we first talked about factoring out a GCF. So if you've got something like 3x cubed minus 18x squared plus 6x, then our GCF is 3x. It's the biggest thing that can be pulled out of all of those. And if we factor that out, we're left with, that's the process of factoring out a GCF. And sometimes for the other strategies, you want to start by doing that. The second strategy we talked about is when there's a leading coefficient of 1. So we've got the GCF strategy, we've got when there's a leading coefficient of 1, and it looks something like this. So let's do an example of that. Okay, so when we go to factor this, we need two numbers, remember, that multiply to make negative 10. And those same two numbers have to add to make negative 9. So we're going to do negative 10 and 1. And this will factor as x minus 10 times x plus 1. And remember, you can check it by multiplying that out. That ensures that my factoring actually works. The last kind of factoring we talked about was difference of squares. So that's going to look something like a squared x squared minus b squared. So in other words, we're going to do a couple different examples. So if I've got x squared minus 36, this will factor into x plus 6, x minus 6. And you can check this by multiplying it out and make sure that works. And then suppose we've got something a little harder, like 4x squared minus 25. Think about what squared makes 4x squared, and it's 2x. So we're going to have 2x and 2x, and then plus 5 and minus 5. And the reason why this has no x term, right, is because it's going to have a plus 10x and then a minus 10x, and those will cancel out. The one that seems to throw students for a loop is if you write it in the other direction. So if you write something like 100 minus x squared, you just have to realize that don't switch the order. The x doesn't always have to go first. 10 plus x, 10 minus x, right? Now, sometimes some of these strategies can get mixed together. What we're going to talk about is just to remind you that the reason why we learned all this factoring is so that we could solve by factoring. And remember, we said set the equation equal to 0, factor, and then use the zero product property. Which means that if you have a times b equals 0, that either a equals 0 or b equals 0. That's what we talked about when we first started factoring or solving by factoring. So solving by factoring, this is the whole reason why we care about factoring. One of the big main reasons why we care about factoring is because then we can solve by factoring. Okay, so let's do an example. So suppose I've got, all right, first I'm going to set this equal to 0. So I'm going to subtract 252x from both sides. And then I've got 3x cubed plus 15x squared minus 252x equals 0. And then I can see there's a GCF, and it's going to be 3x. So I'm going to factor that out first. I'm going to be left with x squared plus 5x minus 84. So I need, this 3x is just going to hang out here. I need two numbers that multiply to make negative 84 and add to make 5. So that's going to have to be negative 12, no, positive 12 and negative 7. So 3x stays here, don't lose it. And then you've got x plus 12 and x minus 7. So now we've actually got three things here. 3x, x plus 12, and x minus 7. They all multiply together to make 0, so that means that either 3x equals 0, x plus 12 equals 0, or x minus 7 equals 0. If 3 times x equals 0, then x must be 0. Here x must be negative 12, and here x must be a positive 7. So there are three solutions. And we could plug them in up here and make sure they all work to check. Okay, here's our new topic for today. And it's going to be factoring, similar to what we did before. All right, but factoring when it looks like this, ax squared plus bx plus c. So this is going to be not 1 this time. So look at what happens. Let's first multiply. So if we've got 2x minus 1 times 3x plus 5. Let's multiply this out. We've got 6x squared plus 10x minus 3x minus 5. So in other words, 6x squared plus 7x minus 5. Okay, where did the 6x squared from? It still came from the two front terms, 2x times 3x. Now, where did the 7x come from? That is way trickier. The negative 5 still comes from the two last terms. So when we go to factor, figuring out this middle term is trickier than it was before. We have to take a little bit more into account. So let's do an example to figure this out. So we're going to have 5x squared plus 11x plus 2. It's going to be similar to what we did before, but not the same. Okay, I'm looking for two numbers that multiply together. This time, instead of just multiplying to make 2, I need them to multiply to make 5 times 2, which is 10. So where does this 10 come from? It comes from 5 times 2. Now they still have to add to make the middle term. Add to make the 11. Okay? So the 11 comes from this coefficient right here. It's a positive 11, so it's a positive 11 there. Okay, so what are those numbers going to be? Well, they're going to be 1 and 10, obviously. Okay, here's where this is different. So notice this part is different. We're going to write 5x squared. Then we're going to take this 11x. We're going to split it into two pieces. These are the two pieces that we're going to split into. We're going to have plus 1x plus 10x plus 2. So this is the new part. Okay, this is obviously the same as what we had before because 1x plus 10x is the same as 11x. But you're thinking, why would we bother doing that? That seems silly. Well, now you're going to consider this part together and this part together. And you're going to factor out a GCF of both parts. Okay, let me show you what I mean by that. Consider this part first. What's the GCF of 5x squared and 1x? It's just x, so I'm going to factor out an x here. And then I've got 5x plus 1. What's the GCF of 10x and 2? It's 2, so I'm going to factor out a positive 2. And then what am I left with? 5x plus 1. Now, this method only works if these two things are the same. Notice they're the same. Okay, so they become my second factor. I'm essentially factoring out a 5x plus 1. Okay? And they come over here, both of these two. We factor out a 5x plus 1. There's not two 5x plus 1s. We factored out a 5x plus 1 from both. And then we are left with x plus 2. Okay, so that seemed a little bit magical. So let's check it. X plus 2 and 5x plus 1. This is going to give me 5x squared, 1x, 10x, 2. So 5x squared plus 1x plus 10x plus 2, or 5x squared plus 11x plus 2, which is indeed what I started with. Let's do one example with some negative signs in there. So we're going to have 3x squared plus 4x minus 15. We're going to factor this. Okay, there's no GCF to factor out here. Nothing divides everything. Nothing divides 3, 4, and 15, and there's no x that I can factor out. Okay, so again, I'm looking for two things that multiply to make. Now here's the tricky part. They've got to multiply to make 3 times negative 15. So this is going to be negative 45. They're still going to add to make 4. This comes down. The 3x comes down, the negative 15 comes down. 3x squared, negative 15. It's just that we're going to rewrite the 4x. So I'm going to use a positive 9 and a negative 5, because that multiplies to make negative 45 and adds to make 4. I'm going to rewrite the 4x as plus 9x minus 5x. And you might be asking, what if you wrote negative 5x plus 9x? And the answer is it comes out the same, and you can try that out to prove it to yourself. Now we're going to consider these two pieces separately, factoring out the GCF. Here I'm going to factor out 3x, and I'm left with x plus 3. Here I'm going to factor out a negative 5, and I'm left with x plus 3. These two pieces are the same, so I'm happy about that. That's my second factor. And this tell me my first factor. And I encourage you to go ahead and check that.